So yes, Likita, introduce yourself.
Sir, my name is Likita. I've graduated in 2020 from a mechanical engineering department. So I have been attempting GATE exams from 2020, but I haven't got any good rank in all these years. Last time my rank was 5,600, and this time is also it's not good. It's 7,800. So I've recently qualified BARC written examination. Uh,
Okay, so which mock do you want to give, like subject wise, topic wise, or like full length?
Sir, actually, as of now, regarding my preparation, I'm confident in strength of materials and in fluid mechanics.
Okay.
Uh, Baki though, there I am good at very basics, sir. I don't know if I can go deep in those two subjects.
Okay. Okay. So okay. So just tell me, what is friction?
Sir, friction is the motion. Friction is a force that is opposing or any motion, whatever motion it is. If you are trying to move anything, it is opposing the motion of that.
Like, can you tell me, like, is viscosity of friction?
Yes, sir. Viscosity I can explain. Viscosity is nothing but the fluid resistance. It is offered. It is the property of the fluid actually.
Hmm?
It is nothing but the resistance offered by the fluid layer to another fluid layer. It tries to stop the other fluid layers successively, and they go on, decreasing their velocities because of that. And we can explain it on the as a drawing on the a plate also. If you allow me, I can draw.
Yes, yes, you can. Please tell. You are free to use.
If I can assume that the velocity with which the fluid is coming is u infinite, after striking to this plate, here the velocity becomes zero due to no slip conditions. And because of the viscosity only, this fluid layer tries to stop this layer, and this layer tries to stop this layer, and it goes on like this. That's why we say shear stress is directly proportional to du by dy, where u is velocity and y is direction.
Okay. So can you tell me, like, what are the various types of viscosities?
Yes, so their viscosities constants are there. There is dynamic viscosity and kinematic viscosity also.
Okay. So what do you understand by dynamic viscosity and kinematic viscosity?
So basically, kinematic viscosity is nothing but dynamic viscosity divided by density. I could feel that kinematic viscosity it is kinematic because there is no kind of force term or mass term in it. But in dynamic viscosity, I can find it kg per meter second. I think that's the only difference, sir. And we here the significance is mu only. Dynamic viscosity is the viscosity we usually calculate
Okay.
for a
So
given fluid.
just tell me, like, how does viscosity varies with temperature?
Viscosity for liquids it is
Yes.
viscosity decreases by increasing the temperature, and for
Okay.
gases viscosity increases by increasing the temperature.
Okay. So just draw the graph of viscosity versus temperature for liquid as well as gases.
చిన్న వెళ్తున్నా సార్ ఏ ఆన్సర్ లేదు సార్
So this is for liquid, and this is for gas. I think for gas I'm not sure, sir.
How will you draw, like, ये विस्कोसिटी होगा, ओके आपका, तो ये रहेगा आपका लिक्विड का और ये रहेगा आपका गैस का, ठीक है। म्यू ऑफ
Oh,
गैस इज इक्वल टू टेम्परेचर, डायरेक्टली प्रोपोर्शनल टू टेम्परेचर के। म्यू ऑफ लिक्विड इज इनवर्सली प्रोपोर्शनल टू टेम्परेचर। ओके, क्लियर? ठीक
yes.
है। Okay, just tell me like what will be the variation of viscosity with pressure?
Sir, I think for liquids, it won't change with pressure. There won't be any significant, I think, much change in the viscosity with change in pressure.
For liquid or gas?
For liquids,
For liquids and for gas?
uh, yes, it may change. It could decrease its viscosity, maybe.
Decrease.
Decrease.
Viscosity get decrease if you increase the pressure.
Uh, Molecules come closer, they won't hit each other if we.
Are you sure that viscosity get decrease when you increase the pressure?
So what reason I'm not sure about this actually, but uh, I think.
In the cases, in the cases of gases, dynamic viscosity generally is constant, but at moderate or low pressure, which is up to 3 to 4 atmosphere. But if there are exceptional cases like the pressure is very increased, in that case, the viscosity get increased. Okay?
Okay. Okay.
Increase the pressure. Fine. Okay. Just tell me, like, what do you understand by compressible and incompressible fluid?
Hmm. Compressible means we can take the example of gases. They're easily compressed. Upon giving a small pressure, they'll be compressed very easily to the required volume, like gases. And incompressible are the fluids we cannot compress upon giving them all volume. They need really more high amount of pressures in order to compress it to a very little volume. This is what I understand by compressible
So
fluid. That's
what?
why we say salt.
Okay. So what do you understand by flow, incompressible and compressible flow?
Compressible flow is the flow in which the density keeps on changing along the flow, and incompressible it won't change along the flow.
Okay, fine. Just tell me about what is surface tension.
Surface tension is the property of the surface of a fluid, surface of a liquid. Uh, it is the units of surface tension in Newton per meter, and uh, mm, it is the property due to which leaves float on water and yes.
Surface tension, okay, fine. Just tell me like what is cohesion force and what are cohesive forces and what are adhesive forces or
Cohesive
cohesion and adhesion. Explain me on that.
Cohesive forces are the forces between the similar particles
Hmm?
of that substance only, and adhesion forces is the property of that fluid to attach with another surface or anything,
Okay.
uh, like water sticking to glass or mercury sticking to glass,
Hmm.
and that. And mercury, the formation of mercury drop is more likely than to the formation of drop of water because of adhesive forces between the molecules in between intermolecular forces.
ओके, तो चलिए अब आपसे एक क्वेश्चन पूछते हैं, है ना? ठीक है। हाँ, तो एक्सप्लेन मी पास्कल्स लॉ.
So Pascal's law can be explained by two ways. If, for example, for this vessel, if I apply pressure on this vessel, it will be equally distributed to each and every fluid particle. The pressure will be transformed into distributed to this vessel and undiminished anywhere. And we all can also explain like this: for a given fluid at the same level, the pressure will be same. That is Pascal's law.
ओके, तो फाइल आई विल बी कंक्लूडिंग योर इंटरव्यू. आप ना आंसर तो दे रहे हैं बट आपके आंसर्स में क्लैरिटी नहीं है. ठीक है,
Okay.
तो फीडबैक देना चाहूँगा. आपके आंसर्स में क्लैरिटी नहीं है. भले आपको आंसर पता है, कॉन्सेप्चुअल नॉलेज है, बट जो एक्सप्रेस होता है, डिलीवरी होती है ना, जैसे आप सरफेस टेंशन का डेफिनेशन पूछा था, आपने उसको एक्सप्रेस करना चाहिए था कि सर इट इज द टेंसाइल फोर्स एक्टिंग पर यूनिट एरिया, राइट? तो
Right. Yes.
कॉन्सेप्चुअल का मतलब वो जो क्लैरिटी ऑफ द आंसर्स होता है ना, वो होना चाहिए। कंप्रेसिव
Yeah.
फ्लो, इनकम्प्रेसिबल फ्लो की बात किया मैंने, फ्लूइड की बात किया, तो कहीं ना कहीं वहां पे भी आपको कॉन्सेप्चुअल नॉलेज लैक किया।
Okay.
ओके,
Okay.
यू आर नॉट एबल टू डिलीवर व्हाट आई वांटेड टू हियर, राइट?
Okay.
एंड इट वाज फीलिंग लाइक आप बोल कर रहे थे, इसलिए मैंने भी आई स्टॉप द इंटरव्यू। ओके,
Okay.
फाइन। एंड थोड़ा सा आप वर्क करिए अपने ऊपर में, बाकी कम्युनिकेशन में तो कोई प्रॉब्लम नहीं है। ओके, एंड मुझे ऐसा लगा कि आप इंटरव्यू बस टाइम पास के लिए दे रहे हैं, बिकॉज ऑफ सुमित का आपका मैंने कन्वर्ट करवा दिया। जब ओके, तो टाइम पास के लिए नहीं देना इंटरव्यू, जब भी आप दे रहे हो ना, तो यू हैव टू टेक इंटरव्यू, डोंट टेक फॉर ग्रांट, राइट? डोंट टेक इट फॉर ग्रांटेड।
Yeah.
यू आर टेकिंग इट फॉर ग्रांटेड कि भाई हाँ देना है देंगे, नहीं देना है नहीं देंगे। ओके, ये चीज आपके दिमाग में चल रही थी, तो फिर ऐसे नहीं हो पाएगा, ऐसे क्लियर नहीं हो पाएगा। आपके सामने मैं आज अकेला बैठा हूँ, वहां पे पैनल मेंबर रहेंगे।
Yeah.
बहुत
Okay.
ध्यान के लिए आपने, ठीक है, फाइन। मैं एंड करूंगा, कंक्लूड